but there might be a little bit with getting them correct. All right. So let me just introduce the first topic of the course and kind of give some motivation to it, hopefully tell a little bit of a story. And so the question is, how do we transport goods from what was considered the West in the United States in the early 1800s? So the West would be things like, at that time, Ohio, maybe Missouri. So the goods I'm thinking about are things like furs or maybe crops. And the issue, right, is, let's say you're a fur trader, you're doing this in Ohio in the early 1800s. Where do the people live that you want to sell your furs to? They don't live in Ohio. There aren't many people living in the West at that point in American history. And so where do they live? They live either in Europe or maybe in the East Coast of the United States. And so how are you going to actually transport those things to New York or to Paris or whatever? How are you going to do that? And so I've asked this many times, many semesters. People's first thought is, well, trains would have been what we used, but this is actually before the Intercontinental Railroad was built. So we don't have that option. I said that one time and somebody said, well, I guess you could find somebody with trains, which made me think that maybe they don't understand exactly how trains work. So what do you think we're going to do? How do you transport your stuff? So wagons is one solution. That would be incredibly difficult, though, with the mountain passes. I don't know, when I was a kid, we played this like Oregon Trail. And Oregon Trail, you know, everyone died of dysentery. Right, so I see a lot of these answers, and what they're going to do is actually try to use waterways. And so you can imagine over here is somewhere where I'm thinking this area is where people are living. And if you look at these waterways, no matter where exactly you're starting from, you basically get on one of these and it's going to eventually end up in the Mississippi River and down here in New Orleans is what you're going to do. So you're going to use these waterways to try to get there. Now I'm from, I kind of grew up in a small town on the Missouri River, and my grandparents were from a small town near the Mississippi River. So we got all these the Weather Channel. I'm not very good at pointing where I'm supposed to be yet, but got a lot of these stories about travel on the Missouri and Mississippi River. But basically what you used is this flatboat. These flatboats you should think of as giant rafts. And basically when the water's high, you're going to float them along with your cargo down these river channels and end up in New Orleans. Now, I mentioned this high water. I don't know if you see on the screen there that branch. These rivers actually have lots of trees and things in them that are very, very dangerous. So you want to make sure that you're not going to get snagged and so forth. So one of the things you had to do is you had to hire these guys to help you float this down. I've got some quotes here just to be ridiculous. And so these are on this side here. It's like they asked this riverman how he loaded his flatboat or barge, and his answer: one squint of his eye would blister a bull's heel, which makes no sense in any world, but whatever. I especially like this last one down here. Billy Earthquake is the genuine double-acting engine, can outrun, outswim, chaw more tobacco and spit less, drink more whiskey and keep sober than any other man in these localities. So that was the skill set you needed to be a great riverman. You know, chew a bunch of tobacco and not spit, drink whiskey and stay sober, all that good stuff. All right, so I'd point this out to highlight the difficulties here. The difficulties in this flatboat trip. But I really haven't highlighted the biggest difficulty. Does anyone see something really big challenge in what we're doing here? We've just loaded up a giant raft with our goods. You know, we had to hire these guys. We had to go down the river, try to avoid all the difficulties on that part of the trip. We've gotten to New Orleans. we've sold our goods, and now I've just taken a raft down the Mississippi River. How the hell am I going back? Yeah, so I see a lot of some answers. But yeah, the biggest problem here is I got to go home somehow. And so going home, yeah, I've got to either buy a horse or I've got to walk. This is a very expensive, time-consuming problem. Time-consuming. Very, very, very big problem. All right, so technology, of course, happens, advances happen. And what I want you to see here is this keelboat, that's the one up there, literally passing a flatboat. And that's basically what happened in the West. People quit using these rafts and instead used a keelboat. It's keelboat because it's got that bottom structure, curvature. And the big advantage of the keelboat was, as you can almost see in the picture, they can, with these oars, you can actually take it upstream. It's not going to be an easy trip upstream, but it can be done, which makes it obviously more advantageous than the flatboat, which you get to New Orleans and you basically take it apart and sell it for whatever and have to get home some other way. So the keelboat has the advantage of being able to go upstream. So these were like what Lewis and Clark took and so forth. And I want you to think of this as like a substitute technology that's somewhat superior to the flatboat. Now, I saw it in the chat a minute ago, but you know, technology keeps changing. What's going to come next? What's coming after the keelboat? And yeah, the steamboat. The big steamboat. Let's see a picture of them. Right. The first successful trip on these rivers happened in 1817, but they really weren't used for another 20 years after that. Here's just a nonsensical quote from Mark Twain. When it's steamboat time, you steam. Sure, why not? But something really interesting happened. The steamboat comes along, and those keelboats, the curvature ones that you could take upstream, disappear. And those flatboats come back. And that begs the question is, why did the introduction of the steamboat lead to that inferior technology making a comeback, where the keelboat had basically replaced the flatboat, but when the steamboat arrives and is practical, the flatboat makes its comeback. And so I guess the question is, what's happened? What is it about the introduction of the steamboat that made the flatboat viable again? Any ideas? Yep, everyone's got it exactly. You take the cheaper option downstream, the flatboat, the giant raft, but now instead of needing to worry about getting back upstream, you use the steamboat to take a trip upstream. And what is the point here? How do you measure the cost of transporting your goods to New Orleans? It's not just the cost of the flatboat or the cost of the keelboat, right? It's not just that, you know, the construction cost or the cost of hiring them. It's also that time cost. And the combination of the flatboat steamboat was cheaper than just the keelboat, not necessarily by dollars, but because of the time savings. And so in economics, we say the way we measure cost is with opportunity cost. That is, and I'll define this term more specifically in a second, it's not just like dollars, it's what you gave up, what you could have done instead. And so, yeah, there's maybe the cost of hiring these people, the cost of the wood or whatever, but there's also how much time did I spend? I mean, if you told me, well, this costs a little extra, but it saves you 2 months, that seems like a great deal to me. I mean, you know, I get stuck on I-95 for 10 minutes, I'm willing to pay, you know, $20 to get out of there or something. So the time cost is relevant. And this is the first kind of economic concept we're going to be talking about is opportunity cost. And so what I want to, we're going to start by thinking of opportunity cost from kind of a society's perspective in terms of producing stuff. The opportunity cost of producing something is what we could have done, what we gave up in order to obtain that. What was our other option? And so this is our first kind of definitional term. Opportunity cost of an item is what you give up to obtain that. As we go through these things in class, I want you to note two things. One, of course, these definitions are in the notes, the book, etc. But the second is, I'm never going to test you on the definition, like trying to be tricky about the wording of it. So what you want to do in writing these things down is try to put it into your own words. What does that mean to you? What is the opportunity cost? And so, for example, one thing we might think about is, I see this in the news all the time. Somebody says, well, you know, this employs people doing job X, but the opportunity cost of doing that is we could have employed them doing something else. The PowerPoints themselves are not available on Blackboard. Of course, you can go through and you know, the video recordings of them are. That said, I will be posting from time to time graphs to Blackboard for you to print out in advance, especially when I have it'll probably be halfway through the semester when we start doing these particular cost curves that are really, really hard to draw carefully. And so I'll post those graphs to Blackboard. Obviously, though, you can go through and look at them in the recordings. Okay, so an example I might say is when you think about where you're going to live here in town, you might be thinking about opportunity cost of the larger apartment. You know, maybe that means you're giving up some of the, you know, maybe that means you have to eat ramen noodles all semester or something. But what you kind of, it's not just the dollars, it's what did you give up? So one I always like to talk about, of course, is what's the opportunity cost of going to college, getting a university degree. And so every time I do this, I ask students, how much is your tuition? How much are you paying for college this year? And everybody gives me a different answer. So crippling debt, too much. Everybody gives me a different answer. But what I want to emphasize is there's tuition cost. There's the cost of the textbooks, which is, if you want to think of something that's really too much, the textbooks are absurdly too much. It's not like there's some special knowledge in those that I could go on a long tangent about that. I'll skip it this time. Losing the good young years of your life. Yeah, I mean, what would you be doing instead is what I want to ask you. What would you be doing if you weren't here? If you weren't trying to do this? Maybe that is living at home with your parents. Not me. That's not what I'd have been doing. You would be working. You'd be trying to earn money, trying to do other stuff. And that is the cost, right? It's not just what you're paying. And I want to emphasize that from an economist perspective, we want to measure all those costs. Now, why might that be really relevant in economics? Let's say I'm talking about a firm's profit. A firm's profit. Now, if I told you, you built this firm, you invested $1 million in it, put $1 million in, and you got exactly $1 million and $1,001 out a year later, would you feel like you turned a profit from that? I mean, you took $1 million, invested it, and got just $1 back. I mean, your $1,001. And so we would say, no, that's not the profit, because you're not counting the fact that that $1 million could have earned money doing something else. So in economics, when we think about the cost, we want to take into account that money could have done something else. It could have earned something else. If I quit my job and start running lemonade stands, and I earn, enough to have like $100 more than I put in, I wouldn't call that $100 a profit, because I gave up, thousands and thousands of dollars doing something else. So we want to account for those costs. Right, so in the first unit of the class, what we're going to be doing is thinking about these costs in the context of production decisions. So we're going to think of a world where we can produce a couple of different goods, and we're going to think of the cost of producing one in terms of what we gave up producing the other. And so this is just a very simple numerical example. And I've got here, suppose that on a Sunday afternoon, Daryl can brew either 2 batches of beer or he can make 3 batches of chili. What is the opportunity cost of a batch of beer? And so the way we want to think about this is I want to think about the number of batches of beer, the number of batches of chili I give up per batch of beer. And so so we want to make it, essentially I see 2/3 as the answer. It's either 2/3 or 3/2. And the way we want to think about this is per batch of beer. So per batch of beer, we're going to put the it's like whenever you hear that thing goes on the denominator. So we're going to have 3/2 a batch of chili per batch of beer. And that's going to be the opportunity cost. So just again, let me emphasize that when you go to solve a problem, the thing you're finding the opportunity cost of, that's going to be on the denominator. So the thing you're giving up is on the numerator. The thing you're finding the opportunity cost of is the denominator. So 3/2 a batch of chili. Okay. So the second definition for today is what's called the production possibilities frontier. What you're going to see in this class is we draw lots and lots of graphs. Every day we're going to be doing a graph. Most days I'm going to be using PowerPoint for a few minutes, and I'm going to be switching to a document camera where I'm drawing and solving things on the document camera. What is the production possibilities frontier? This is a graph that shows, so all these words, we want to put it into our own words. It's just a graph that shows us the combinations that can be produced, the choices that are out there, the things that our technology, our resources would allow us to do. Now, right in the world, we're thinking about this across millions of different goods. This is the amount of computers and Diet Coke and cars and all those combinations that can be produced that form this production possibilities frontier. Now, what we'll see in this class is we're always going to be simplifying this frontier down to 2 goods. So we're going to have 2 dimensions. Why are we going to do that? Mathematically, we don't need to do that. So I could write down in goods and solve everything the same. But graphically, I can't draw past 2 dimensions very well. So we're going to always kind of assume it's 2 goods. What I want you to recognize is there's no reason it had to be that other than we just needed to do that for the graph. All right, so this production possibilities frontier, I want you to write kind of above that PPF, because that's what I'm going to use as kind of, because I'm lazy and I'm not going to write that out every time. And so the PPF, what is it? It's just a graph that shows us what can be made. What are our options? So this is a graph taken from one of these textbooks that's showing maybe computers on one axis and cars on the other axis. And I just kind of want to walk through what is this graph? What is it showing us? It's showing us all the combinations of cars and computers that can be made. So point C, it's outside. Point C, where is that? Where is point C? There you are, point C. It's outside of the frontier. What does that tell us? What's true about point C? Well, you can't do it. Yeah, it cannot be achieved. There's no combination of resources and allocations that actually makes point C happen. Point D down here lies within the frontier. The notes for each section in top hat. So in top hat, you're going to see the reading, the 2 quizzes, and my notes with videos embedded. They'll be, for each week, you'll see that. So point D down here is an attainable point, but notice at point D, there's a way to redo things that would give us more cars and more computers. right? Point D is kind of wasteful. It's technically inefficient in that there's a way to get more of both. Points A and B, and any point along the frontier, we face a trade-off. If you want more cars, we're going to have to give up more computers. You want more computers, we have to give up more cars. And that's that opportunity cost concept. And we'll tie that to this picture in 1 second. But take away from this picture, the frontier, that along the curve, that's where we face the trade-off. Outside the frontier, impossible. Inside the frontier, there's kind of a better way of doing things. All right, so the first example, the example we're going to be going through, and I'll switch the document camera in just a second to do this, is suppose we have 100 units of labor to divide between gun production or butter production. So each unit of labor can produce either 2 guns or 5 units of butter. So the first question I'm going to ask you is, what is the opportunity? Well, before I do that, why, you might be saying to yourself, why is the professor talking about guns and butter? This sounds ridiculous. So let me just give you a little history of this. This term, guns or butter, is used to refer to the idea of society having a trade-off between consumption goods like butter and defense or military spending, guns. And as near as I can tell, the origin of the term dates to the First World War, when there were bills that were passed to fund production of factories that would be used to create guns during the war, and then would be converted to domestic production after the war. And this was termed guns and butter, and kind of has is now commonly used. So like there's a West Wing episode entitled Guns and Butter, and I just hope you get that context of when that term is referring to that trade-off between consumption and military spending. There's also a song by the illustrious A$AP Rocky referring to guns and butter, which I attempted to try to ascertain whether that was getting at this trade-off, but I believe I failed to understand it correctly. All right, so back to the example here. We have guns and butter. 100 units of labor to divide between guns and butter. Each unit can either produce 2 guns or it can produce 5 units of butter. So think of that 100 units of labor as people. Tom, Sam, Sue, Billy, whatever. Everybody's got a name. Each person, you can tell them, hey, go make guns, and they can come back with 2, or go make butter, and they can come back with 5. They can't do both. They have to choose which one they're going to do. So what's the opportunity cost of 1 unit of butter? Remember, we're going to put the thing we're finding opportunity cost of on the denominator. So we're going to do 2 guns per 5 units of butter. So the opportunity cost of butter is 2/5. It's 2/5 a gun. That's what we gave up. All right. So let me draw one of these. Let me see if I can. Zoom in just a little bit. Would you stop doing that focusing thing? Okay. Sorry about that. Let me turn this autofocus off a second. Okay. If you have a question, just go ahead and ask in the chat. So we've got 100 units of labor. What's my favorite A$AP song? I try to keep things appropriate in the chat. 2 guns or 5 butter. Each person can do that, right? So what we're going to do is we're going to take a graph, and what we're going to put on each axis is guns or butter. Now, which one goes on which axis is kind of irrelevant. I mean, it's arbitrary. but it does affect the interpretation of some things. So I'm going to go ahead and put butter down here. That's kind of just an arbitrary decision. I decided to put butter on the horizontal axis, and I'm going to put guns up here on the vertical axis. And so I want you to think about, as we do this production possibilities frontier, what we're doing is telling each of those 100 people to make either guns or make butter. And so what we're going to be drawing is all the combinations of those 100 people making guns or butter. If I tell all of them to make guns, everybody, hey, you go make guns, how many guns are we going to produce? So we're going to make 200 guns, because 2 guns times 100 units of labor, 200. On the other hand, I could tell everybody go make butter. And I could get 5 units of butter per person times 100, 500. Notice I have no guns in that case, and in the other case, I had no butter. But there's a bunch of other combinations I can have, right? I could have 99 people make guns and 1 person make butter. If I had 99 people make guns and 1 person make butter, I would get 198 guns and 5 butter. I could have 98 people do guns, in which case I get 196 guns and 10 butter. So every person I move over, I go down 2 guns over 5 butter. Down 2 guns over 5 butter. Every person like that. That is, it has a straight line where I'm going down 2 over 5, down 2 over 5. So the slope here is minus 2/5. I'm going down 2 over 5. Now, that 2/5 maybe should make us think of something. Yep. What was the opportunity cost of butter? The opportunity cost of butter was 2/5, right? So here, this slope, the production possibilities frontier, let me go where I can write it. This slope, this 2/5, now the negative refers to the fact that it's a cost, right? It's a trade-off. But this is the opportunity cost of the x-axis good, because it's telling us how many units of guns we go down per unit of butter we go over. So that, again, first connection we're making here from the graphs, the slope of the production possibilities frontier, ignoring the negative part, the slope is the opportunity cost of which good, the good on the x-axis, because we're going down on the y-axis per x-axis. So the x-axis is the one in the denominator when we're finding that slope. So that's the one we're finding the opportunity cost of. So it's arbitrary which one I put on this axis, but if I put guns down here, we'd have the slope being 5/2, because what's the opportunity cost of guns? It's just the reciprocal of butter, 5/2. Okay. And where am I? There you are. Okay. This is a production possibilities frontier. We found the opportunity cost of the x-axis good is the slope of this production possibility frontier. Well, in this example, everybody was the same, right? There were 100 people, but they were all identical. And so what we're going to be, kind of the hard thing we're going to do today is actually try to add in, well, what happens when they're not the same? So maybe we've got this region that looks like this, region W here, but maybe we have another region that is different productivities, where the people in that region, it's not 2 guns or 5 butter, but maybe they have a different opportunity cost. And what's that going to look like? So this says 10. I mean this to say 100, just like same examples we were just doing. Not 10 units labor, 100 units. So you've got a region W that was exactly like we had before, But now I've got a region M down here that can produce 2 units of guns, but not 5 units of butter. They can only produce 2 units of butter. So people there can produce 2 guns or 2 units of butter. So I want you, again, to belabor this, because if you kind of understand this point, it'll make solving what I think is the hardest problems we're going to have for exam 1 a lot easier. And the point I want to belabor is, as we draw that production possibilities frontier, each point is you telling the 100 people in region W and the 100 people in region M what to do. You're telling each person, think of them with a name. The people in region W, Sam, Billy, all those people, they have a last name W. The people in region M, they have a last name M. And you've got to tell each of those people, I want you to make guns or butter. All right, so let's flip back to the dot camera. So now I've got this 100 units of labor that can produce 2 guns or 5 units of butter. That was the region W we just did. I've got another region over here that can produce 100 units of labor. I'm sorry, has 100 units of labor, can produce 2 guns or 2 units of butter. So we've got 2 regions together. All right. I'm going to go ahead and put butter on that axis. Again, that's arbitrary. So now what I'm going to be doing is telling the people in W or the people in M produce guns or butter. If I tell everybody in W and everybody in M to make guns, how many guns will I get? Not a trick question. Tell everybody everywhere to make guns. 400, you guys got it. Why 400? In W, 2 guns per 100 people, so 200, 2 times 100. And in M, everybody can make 2 guns per 100 people, 2 times 100. Add them together. So think of this as M plus W. If we have them together, what will we get? We can get 400 units of guns. On the other hand, I could have everybody make butter. If I have everybody make butter, 5 times 100 for 500, 2 times 100 for 200, add them together, 700. Okay, now this is the tricky part. What happens in between there? So yeah, Evan, you kind of got, you're on the right track here about where we're going with this. What if I start here? The way I'm going to do these is I'm going to imagine starting up here. So here we're not doing trade yet. Here we're thinking of them like everybody's all together. So yeah, it's all the other possible combinations, but some combinations, if you remember that graph, let me pull it back up. Remember this graph? We had this point D down here that I said was technically inefficient. Some combinations are going to be technically inefficient. What would be an example of that? If I told somebody in region M to make butter and somebody in region W to make guns, why is that technically inefficient? Well, because if I did that, I said, hey, you know, M guy over here, you go make butter. He comes back with 2 units of butter. And I tell W guy, you go make guns. He comes back with 2 guns. I got 2 guns and 2 butter. But if I flip them, the W did the butter and the M did the guns, I would have 3 more units of butter. And so the idea is I want to assign people based on their opportunity cost. So the way I'm going to think about this is start up here at 400 guns. I've got 400 units of guns, and I want one person to go make butter. Who, like, what region or what group of people am I going to ask for that first person to switch from guns to butter? Exactly. I mean, I have a W person. Because, hey, if I switch the M person, I just get 2 units of butter. If I switch a W person, I get 5. And so I'm going to start switching. Maybe 1, then 2, then 3. So these are, again, all the combinations I could do. As I move along this line, what am I doing? I'm having some people in W make guns and some people make butter. So in W, some of those people are doing both. But in M, all are making guns. Right, so in M, everybody's still making guns, but I'm telling some people with the W last names to start making butter. And I keep doing that until I reach the point where 100 people have switched to butter. That is, there are no more people in W left making guns. And so this point is where they're completely specialized. W is all butter. M is all guns. After that, I have to start switching people in M. So let's just kind of fill in the graph a little bit. What's the slope up here? Well, first, what is this point? What are the numbers that go with that point? Well, that's where W is doing all butter. So this is one of these spots where today it's like, oh, the introduction's going easy, not too bad. Now we're going to do something that starts to get a little tricky. How do I find the numbers that go with that point? It is 500 butter and 200 guns. How did I get that? So it's not, I'm not asking just like numerically how did I get that. Like, we just got to think logically, what's happening here? This is the point where W has switched all to butter. So I can get 5 times 100 from W. But we've still got everybody in M doing all guns. So we've still got 200 guns. What's the slope of the line segment up here? Not 4/7 would be the slope of a line if I connected them straight through. The slope of that top line segment is, I'm going down 200 over 500. It is minus 2/5. That is, it's the opportunity cost in W, because that's who's switching. In W, right, as I move a person from guns to butter, I give up 2 guns and move over 5 butter. Give up 2 guns, move over 5 butter. Once I hit this point, though, if I want to add another unit of butter, where do I have to get it? Where does somebody have to move? M. M has to move. And so in this point, it's minus 1. That is the opportunity cost of butter in M. So the slope is still representing the opportunity cost, but the opportunity cost is now not a constant for the whole region because it differs from W to M. Okay. Yeah, so I always start at the one on the vertical axis. We could do the exact same thing thinking about starting on the x-axis. It just, since I tend to think about writing down the opportunity cost, like, how did I know to go with W first? I knew to go with W first because they had the lower opportunity cost of producing butter. And so I started with them and then moved to M rather than the other way around. Slope will never be positive because the idea here is a trade-off, right? I'm giving up producing one thing in order to produce something else. If we had lived in a world with a positive slope, that's like, you know, nirvana. That's where we get free lunch. You can get more of everything. So the negative slope is that we give up one in order to get the other. So the opportunity cost in this example is 2/5 if we're producing less than 500 guns, and 1 if we're producing more than 500 guns. So there is not a single opportunity cost. So if I asked a question, I would say, what is the opportunity cost if you're producing 300 units of butter? And you'd say, oh, that's 2/5. So the -1, I get two ways. One is on the graph, I'm going down 200 guns and over 200 butter. So -200 over 200 is -1. But I can also look up here and just say, well, what's the opportunity cost of butter in M? Well, it's 2 guns over 2 butter, so 1. And it's a cost, so it's minus. All right. So this is kind of what this is called a joint production possibilities frontier. But part of why I wanted to do this today, right off the bat, is I kind of want to go back and think, here I've got 2 regions that are different. But obviously in the real world, everybody's a little different. And there are lots and lots of different regions and different abilities. And so what would you think is going to happen if instead of just the 2 regions, we had 3, 4, 5, 6? Well, if you think about it, we're always going to start with the lowest opportunity cost. So up at the top, we're going to start with, somebody with a fairly flat slope. And as we switch, it gets steeper and steeper. And so when I go back to this graph, from this textbook, why are we representing the graph this way? When in the problems we're going to do, the graphs are going to be straight lines. Where's the disconnect? The idea is what they're doing here is combining lots of different people with lots of different abilities, and then it kind of looks like a curvature, because at first, where you're producing or in this graph, if you're doing all computers, am I freezing? No, okay. If you're doing all computers, up there 3,000 computers, and you want somebody to produce cars, you're going to have somebody with a low opportunity cost, somebody who can produce cars without giving up many computers. But eventually, you start having more and more costly people that you have to switch, people who give up a lot of computers to get a car. And so this graph, I just want you to, when you see it in these books, realize it's just kind of aggregating the kind of problems we're going to do with lots and lots of people and lots of differences. Okay. So this graph we're thinking of as just a snapshot in time, a single point in time. We could imagine that this changes over time. As our technology improves, you would expect these graphs to kind of move out, to shift further out. Right? If we had some technological change that if we had some technological change that made producing butter easier for everybody, what would you expect the new graph to look like? Well, you would expect it still to have some curvature. So it might start in the same spot up here, but further out on the butter axis. And so that would be some improved technology from butter. Yeah, so right now I'm thinking of the joint production possibilities frontier. That's what the books are showing you. When you look in the book and you see that nice curve, it's a joint production possibilities frontier with people with lots of different regions. Okay. Joint PPF. All right, so I'm going to be stopping here in just a couple minutes and taking questions. I know it's the first day, so there might be a few more questions, but let me motivate. Right, so right now we have no time to mention, but if you could imagine so we're thinking of all these productivities for a fixed amount of time. So it's like how much I could produce in a day or how much I could produce in a month. And so the graph would represent our production in a fixed time window. All right, so what are we going to do with this? Yeah, so in right now, everything, your units of labor, your productivities, all of these are fixed. What we're going to be doing next time is thinking about how differences in these productivities can lead to trade, can lead to kind of mutually advantageous trades. And I'm going to try to show you how this simple little model that we're doing can actually explain part of a big thing that's happened in the world over the last 40 to 50 years in terms of globalization and the wealth of countries, but also kind of inequality within countries as well. All right, so I'm going to, before I do that, let's do one more quick poll question. So again, these are a chance to get a point, extra credit. And let's just do a silly one again. So these go to filling in points for those quizzes or reading assignments. They won't go automatically. I have to update them at various points in the semester, but so what's your prediction for next year's record? Yeah, so so let me first, here's a polling question. This is just going to be a point. The way this is going to work is every few weeks, maybe probably at the end of after the first exam, I'll put a column in Blackboard that will show you how many of these you guys got all the way. Well, you know, after watching Bama last night. Oh, curling. I love curling. Usually I'm going to count them correct no matter what. Yeah. Let me keep the. Oh yeah, the under. No, not with that offense. You got to take the over. Okay. So yeah, this is what our class is going to look like. If you guys are you know, I'm done for today. I'm going to close this poll question and stick around here for a few minutes for people to ask any of those questions. I saw one was about exam format. The way the exam formats will be is for the midterms, it's 40 multiple choice questions. There's going to be a randomization component, so not everybody's getting the same thing. Yes, we do have class on Thursday, so we're going to have class typically during the time scheduled, although usually I'm going to try to not make it the full hour and 15 minutes. I know this is a little too much, and try to rely on the recordings. Yeah, I need to stop the recording. Oh, 1 second, guys. Sorry about that. All right. So let me go through as many of these as I can without missing some. The lectures are posted automatically by Blackboard Collaborate Ultra.